The second type of sequence that we're going to focus on is the geometric sequence. And here's the definition. It says a geometric sequence is a sequence where the ratio of every pair of successive terms is constant. So if you take any two terms and you divide them, you're going to get a common ratio or a constant ratio. And all that really means is that you have a constant multiplier. So there's a multiplier between the terms. And in Algebra 1, this is the type of sequence that we started with, like, for example, the number of upward pointing triangles in Sierpinski's triangle generated a geometric sequence. There was a constant multiplier, and we learned that those related back to exponential functions. Now in Algebra 2, we're going to actually open up sequences that are geometric to a little bit more, because if you remember in an exponential function, that multiplier had to be positive. But when you talk about geometric sequences, that's not always the case. This is when you're going to get those alternating sequences I talked about earlier. For example, 80, negative 40, 20, negative 10 is an alternating sequence because the terms alternate from positive to negative. And this one is geometric, and I can verify that because if I take negative 40 and divide it by 80, or 20 and divide it by negative 40, or negative 10 and divide it by 20, in every single one of these cases, I get a negative 1/2. So this negative 1/2 is my common ratio. And if I want to write an apparent formula for it, or the general a sub n term for this sequence, I start off with 80, and I have to multiply it by negative 1/2. And remember from our work with Sierpinski's triangle and those fractals in Algebra 1, if I have a constant multiplier, it's the same as raising it to a power. When I plug in a 1 into my formula for sequences, I better get that first term. And so that exponent is not correct because it would give me the negative 40. So actually for the first term, I don't want to actually multiply by negative 1/2. So I take off a 1 to shift it back down to the 80, and this is my formula. And it so happens that every single geometric sequence is going to have a similar formula. And so its general formula is this. So a sub 1 is the first term, r is my common ratio, the nth term is denoted as a sub n equals a sub 1 times the ratio raised to the n minus 1 power. And we figured this out way back in Algebra 1. Now, what we didn't talk about in Algebra 1 was the geometric mean. I can give you two terms of the geometric sequence and say that there are terms in between, and those terms in between are the geometric means. Now, with geometric means, you have to be careful because how many means you add in can mean that you have one answer for your geometric means or two. Case in point, I want you to insert 3 geometric means between 2 and 32. I have a 2, then 3 terms, and then a 32, such that these terms all have some multiplier. And so I have to figure out 2 times what times what times what times what gives me 32. And so if I think about the multiplier from 2 to 32, it's multiplied by 16. But I have to do that in 1, 2, 3, 4 steps. So I take the 4th root of 16 and I get 2, which means my 3 geometric means should be 4, 8, and then 16. Now, notice here I said there are 2 answers. And the reason I have 2 answers is because I'm inserting 3 of geometric means. Because remember that what this ratio could have been, it could have been negative 2. Which would generate different answers. Because if I use negative 2, then I would have the sequence 2, negative 4, 8, negative 16, and 32. And this sequence here, or those 3 geometric means of negative 4, 8, and negative 16, are just as valid as the positive ones. And it's because I'm inserting 3 geometric means. If I were just inserting 2 geometric means, then I can't have alternating signs unless that 16 is negative. 2 geometric means would fix the signs so you don't have to worry about the alternating. But if I ask you to insert 3, then you got to be careful. You have to stop and think, can you have positive or negative answers? Now this leads us to the geometric mean of A and B. Like the arithmetic mean when you were in, 6th grade or 5th grade. Well, the geometric mean has a definition that's very specific. And the geometric mean of A and B is the square root of the product, AB. Now here's what's special. If I just want one geometric mean, you have to follow this sign criteria. You don't worry about it being alternating or not. If A and B are positive, then the geometric mean is just the positive principal root of AB. And if A and B are negative, then it's the negative root of A and B. Now there's one type of mean we haven't gone through. When you get to statistics, you have arithmetic means, you have geometric means, and there's a third type that we don't really go over, and it's called a harmonic mean. And if you want to know about that, you can just look it up.